We have already seen one implementation of the GGA functional, which is the PBE implementation. But of course, this is not the only one. There are several of them, and the others are also, sometimes they are also quite often used as well. So here, I'm going to give you the reference of 3 more implementations of the GGA. And besides that, I'm going to describe very basically, in very short lines, the main philosophy behind each implementation. Okay, the first one is going to be the B88, that exchange functional. This is the GGA functional just for the exchange. And it was derived by Becky in this reference here in 1988. Okay, this is the philosophy behind this implementation of this GGA function. So the Becky 88 exchange functional is formulated as an additive correction to the LDA. It consists in a compact function of n and the gradient of n chosen so as to satisfy the exact asymptotic behavior of the exchange energy per particle, which is this one, and it can be easily proven to be this one. So it has been constructed in order to satisfy this asymptotic behavior when r goes to infinity of the exchange energy per particle goes as 1 minus 1 over 2 times r. Besides that, there is an empirical parameter which is fitted to the Hartree-Fock exchange energies of rare gas atoms. So they have a parameter which is fitted to that. Okay, this is the first one. The details, you can go to this reference in order to see the exact expression of this parameterization. Okay, let's go to the second one. And the second one is the lip correlation function, which was proposed in this reference here by Lee, Jan, and Carr in 1988 as well. So the lip correlation functional is one of the rare functionals that have not been constructed starting from the LDA. Actually, it originates from the Cole-Salvetti correlation and the approximation. You have this reference here for this correlation functional, or this, depending on the Hartree-Fock per density and containing 4 parameters fitted to helium data. So that was another functional just for the correlation function. So some ones are using the Becky 88 for the exchange correlation and the LIP for the correlation one. So this is another one, and another one which is also used a lot, very similar to the actually very similar to the PBA that we have described before, is the one which is called the PW91 functional, which was derived by, especially by Perdue and Wan, and you can see the details of this functional in this reference here. So the PW91 GGA exchange correlation functional is based on a model of the exchange hole and of the coupling constant integrated correlation hole. So the idea, in the same way that was used for the PBE functional, is to start from the GEA model of these holes given as gradient expansions and to remove the unrealistic long-range parts of these holes to restore the important conditions satisfied by the LDA. And which are these ones? Specifically, the spurious positive part of the GEA exchange hole. So you make it 0 when you have that the exchange hole it's positive. So this part is completely removed. And similarly, a cutoff is applied on the GEA correlation hole to enforce the condition that the hole has to integrate to 0. So the first point, when the correlation hole integrates to 0, it's include up to that, and from that value on, it's make to 0. So this is the kind of cutoffs that are included for this PW91 functional. Again, if you want to look at the details of the specific expression for that function, you can go to this reference here and you can have this expression here. And you can see the philosophy behind that. It's very similar to the PBE functional. And actually the PBE function somehow is a simplification of this PW91 function that actually works pretty well. That's why it's more commonly used than this one, even though that both functions are following the same philosophy. So here I have just shown you different other different quite common as well GGA functions that are also used for different in many calculations.